Today I'd like to talk about rainbow formation. Let's start with this bow right here. Notice it's more than just Roy G. Biv. We're seeing a white washed out area in the interior. We're seeing much darker sky in the exterior. And then we have a secondary bow with reversed colors. So we would like to explain all those features. I'm going to use GeoGebra for my construction, but I've created this little specialized tool that implements Snell's Law. So if I click this tool, and then I click the first 2 points, and then the line where the refraction takes place, I type in an index of refraction, it gives us the refracted ray. So that's done with the geometric construction, and it's captured here in the Tools menu. To apply the Snell tool to a raindrop, what I do is I first create a tangent line, then I use the tool to construct the original bend, and everything after that is just symmetry. Here there is one reflection. This is the ray that creates the primary bow, and there's 2 reflections, and that's the ray that creates the secondary bow. I now have 2 paths, one for the red and one for the blue end of the spectrum. The key insight when you start playing with this is to realize that if you go straight in, you come straight out. As the ray is more and more offset to the side, the deflection increases, but then it goes through a maximum and turns around. And it's at that turnaround point that we get the rainbow. In here, we have all of the different colors, so we have white light. But notice that the cone of red light is larger than the cone of blue light, so we have overlap beyond the blue cone, and we see the red end of the spectrum clearly delineated. The blue end of the spectrum is washed out because we have red and blue combined in that region. If we go to 2 reflections, it's forward scattered, but there is a maximum angle again, and it's finding these maximum angles that determine the angles of the rainbow. So if I take a drop that's anywhere in this region, it's going to scatter white light to our eyes. If the drop's about in here, you're going to see the blue end of the spectrum, and out here is the red end of the spectrum. And then out here, it's scattering the light somewhere else. So in this part of the sky, that accounts for why it's relatively darker there. This is the apparent rainbow in the sky. And again, notice that we can correlate the appearance of the rainbow with the light coming from individual droplets.